Hello everyone.
Okay, so I'm going to start the big plumbing project today and clean up this rat's nest plumber's nightmare up here. The whole purpose of this project really is to get this whole wall cleared. I need the full, from that corner all the way over to here, out of the way for the electronic equipment I'm going to be installing here, or I'm planning to install. The plan is that there's going to be a sub panel here. That's the main panel there. There's going to be a sub panel here. And here will be the all-in-one inverter, the EG4 18K PV. The Powerwall battery will be beneath it on the floor here. And there'll be another Powerwall battery over here. That's the plan. In order to make that happen, I need to move this water softener unit that has never been used since we moved in here. It's always been bypassed. It was never even plugged in. There used to be a well on this property, but we now have city water or county water, so this is not used anymore. So that needs to get out of the way. And the water heater, unfortunately, is in the way because the Powerwall battery, the Power Pro battery, needs 12 inches of space next to it, clearance. So there's going to be a battery, 12 inches, and another battery. And this is too close to it. So I have to relocate this water heater, and I'm going to move it that way close to 8 feet to get it into a good position. So the first thing I need to do is get rid of this thing, and these pipes that come from all the way over there, they're never going to be used again. I'm taking them out. So let me get started. So I've turned off the water main, the gas main outside, and unplugged the water heater. So the first thing I need to do is relieve the pressure on this system and drain these lines out. I'm going to try this. This valve has a drain on it. I'm not sure if it's going to be on the right side to actually work. Okay, there's nothing coming out of there. I actually heard a little gasp of air when I removed it. It had a little bit of pressure differential on it. Alright, well, that means I have to remove this one up here. Geez, the little rubber seal is really stuck on there. So since I know there's no water down here, I'm going to go ahead and cut these pipes and get this out of my way. I put that plug back on up here, but once I get these pipes out of the way, I'll have it'll be a cleaner place to drain without all that spraying and overspray. This pipe had water locked in it for more than a decade, probably. This thing is a lot heavier than I thought it would be. Just get it over here for now. Okay, I've opened up every valve upstairs, every sink, every bathtub, every shower. I'm trying to drain all the water out of the whole system out here. I don't want any water coming down these pipes while I'm working on them, if I can help it. Okay, that's drained out as much as it can be for right now. So it's time to drain the water heater tank. And I'm doing that with a hose that's running over to the sump pump. I connected the hose here to this valve and opened it up. And I don't know if you can hear it, but I can hear the water running out. And in a second, we'll hear the sump pump coming on. Okay, the pump just ran and stopped. There's water flowing out from the water heater tank. Yep. Okay, it's going to cycle a few more times before that tank is empty. There's a ton of heat coming through this so-called protection mat here. Ton of heat. Might stop the flame, but it doesn't stop the heat. Wow. So I would say if you're using one of these heat blankets, high temperature advantage. You can't have the flame directed directly at it. The heat goes right through it. It didn't get hot that time when I was directing it kind of away from there. Well, for some reason I can't heat this one up enough to melt the solder. And there might still be some water in those lines keeping them cool. I'm going to cut it.
Water in the pipes was definitely the problem.
Yeah, that's why. It's full of water, that's why I couldn't heat it. There's still too much water dripping through it. I've got to wait till it stops.
Even after it seems like it stops dripping, there's always more to dry out. Heating the pipe will dry it enough. I'm trying to save these particular pipe ends for reuse, otherwise I'd just cut it.
That'll help get some water out.
My torch was acting up like that because there was a bit of debris lodged way down inside it, where the gas and air mix. It wasn't helping my efforts. I eventually tried blowing it out with compressed air and it began working fine.
So I managed to push that back maybe up to ½ inch, more than ¼ inch. So there's more space in there. So I'm just going to go ahead and saw it off.
I could do that now and still preserve the fittings and pipe ends.
So the water's coming from upstairs here.
This is the water main coming from the meter. It enters a T here. Water flow takes this path out to the water softener. Water flows this path from the water softener. It flows this path from the water softener, then this way to the water heater cold supply. This is crazy. It also extends over the beam to the back corner of the house, here. This is a bad spot to work in, so I simply cut these pipes. This ½ inch pipe comes off the T at the top of the main supply. It feeds unsoftened water only to the outside hose bibs. Here's a better look at that main supply T. It's disconnected from the main supply at the bottom.
That's closed.
This pipe wasn't really even tight. The gas main is turned off, but there's still a lot of unpressurized gas in all the long pipes. It's smart not to take a risk by leaving it open. I also don't need to smell gas all weekend while I'm working down here, so I'm plugging it up. Notice the background sound. I have a strong fan blowing air out through the open window to clear the small amount of gas that escaped. You can tell it's working by the leaves outside the window moving in the breeze created by the fan. It's time to start putting it all back together again. I started with the cold water supply pipes and ended my first day of working on this project with the cold water system in the house fully pressurized and 100% leak-free. I reused a lot of the original copper pipe. Here I am preparing 3/4 inch copper for soldering into its new location and purpose. If you're interested in a lesson in soldering copper pipe, please check out my tutorial video on that subject. I finished this entire project with 100% leak-free pipe joints on the first try. It's actually pretty easy. There was originally a solder joint on this end of this pipe, so I'm sanding the pre-existing solder that's on it as well as the bare copper. As far as I can tell, pipe joints with residual solder on them work just as well as joints that start with bare copper. I just make sure to sand the solder layer very thin so it doesn't interfere with the fit. Here I'm making up the pipe that connects to the output of the water meter. Note that I have not disconnected the water meter from the water main valve. There's a seal on that joint that can't legally be tampered with. I'm putting a brand new ball valve on this side of the meter as well. The inside diameter of these pipe bends have also been deburred. The soldering process would fail without soldering flux.
So after wrestling it around a bit, I got it in line. Here's a plumb bob. I got that cold water inlet, which I replaced that fitting. It's in line with the cold water pipe above.
It doesn't make sense to show you every single pipe joint being soldered, but this intersection of several pipes is pretty interesting. This one gave me a little trouble. It wasn't heating enough to melt solder. As we'll see, it still had some water in it.
It must have some water in it.
Watch what happens.
I might have got it. So it's the morning of day 2, and this is what I got done on day 1. Obviously, the water softener tank is gone. All the plumbing that supported that, all those pipes are gone. The water main now comes directly into here instead of going all the way down to the water softener. These 1/2-inch pipes here actually go out just to outside spigots, hose bibs. And I was a little concerned that these might leak because they're kind of complex for soldering. And this is the only one that gave me any trouble soldering here in the whole project so far. Well, once I pressurized everything, there's not been a single drip. There's not one leak. So if you remember what that water main looked like, this is what it looks like now. I cleaned it up totally. And here's the feed, the water main feeding into the hot water tank. So everything's pressurized, or I should say all the cold pipes are pressurized now. And we had water up in the house overnight so we could actually flush. And getting ready to start working on the hot water pipes. I didn't see the need to record the hot water pipe fitting. It's finished and insulated. I'll show you more later. But now I'll show you some of the black pipe work for the natural gas hookup. Time to start working on extending the gas pipe. I moved the water heater to the left as you face it, so the pipe needs to be extended that direction as well. My first cut on the 3/4 inch black pipe is going to be 40 inches. Cutting black pipe requires a heavier pipe cutter. Here's what I've been using on copper, and here's the one for black. And they're both rigid brand. Now this section here doesn't have to be deadly accurate. I'm going to put a little oil on it right where I'm going to cut. Help that cutting wheel. This length doesn't have to be incredibly accurate. It could be like plus or minus 2 or 3 inches in the location where it's going. No big deal. And it cuts right off, just like you're cutting copper pipe. So I'm just going to use a file here to put it to deburr it, and going to deburr the end and put a chamfer on it so that the die can start on it. olive oil on there. This is a 3/4 inch pipe cutting die.
Reversing to clear the chips.
I like to keep the threads oiled while I'm cutting them. There's one thing that I've noticed on the internet. All kinds of guys that are really good at all sorts of mechanical work and fabrication. And they like to drill and tap dry. Nobody uses cutting oil. You gotta use cutting oil. If you want your tools to last. About 3/4 inch. That should do the job. I'm going to use a lot of pipe dope on these threads. That's probably tight enough. I'll go a little more. That's tight.
So it's the beginning of day 3 now. As we can see, from here all the way to the corner, there's nothing in the way along the floor. There's some junk here I need to clean up. I made a big mess doing this job. Today is mostly going to be cleanup. On day 1 I worked 10 hours, day 2 I worked 9 hours, but at the end of day 2 we all got to take a hot shower, so that was nice. My goal here is accomplished. I have all the space I need to install the electrical equipment I want to install here. So let me show you what I accomplished on day 2. I'll show you the work that was done. So we can see here the water heater's all installed in its new position. At the end of day one, I had the cold water supply piped into the tank. Now it's turned on and the tank's pressurized. It's been filled up. We've used it to heat water. Yesterday I started with adding this output pipe. It feeds the water out to the hot water system. And that goes through that pipe. Here. And tees in right here. And this is the hot water distribution. It goes that way toward the downstairs bath and then the upstairs bath, and then that way toward the rest of the house. So that hot water distribution line comes across here, goes out that way toward the kitchen. This little stub out I had to put a plug on. I guess I had the choice. I could have put a plug on there or taken it out and put a connector in here. I opted for the plug. It's just easier. 100% of my solder joints on the whole project are good. I didn't have one single leak. If anything, I was worried about this one because it had some water in there. I know it did. And it didn't seem to heat properly, and the solder didn't seem like it was flowing properly. But when all is said and done, it's sound. There hasn't been a drop of water here, so that's a good joint. Then I insulated the new hot water pipes to finish it off. So after I was done with all the water piping, and that was completed, I purged all the air, pressurized the system, purged all the air, and checked for leaks, and it was perfect. So this is the point here. If you remember earlier, I put a plug in the gas pipe. So I needed to work on rerunning the gas pipe over to the new water heater location. So I removed that plug. I cut that length of pipe there. It comes over to here, drops down, continues over this way. And then these pipes here were the original. So I just extended this over to here. This is the new 3/4 inch pipe. I stepped it down here, reduced it to 1/2 inch. This is the original 1/2 inch pipe that I disconnected earlier. The original 90 across here. This original 90, it's actually a T with a plug, but that's what was on it originally. And this one I had to shorten and rethread. But there it is. It's all piped up and it's holding gas pressure just fine. I put a good solid hanger here with a beam clamp right off the beam. So that's good. And that's supported over there very well. This end of the pipe though is just a little bit shaky. I don't like it, so I'm going to add another hanger there just to make it more solid. Other than that, that's good. Once I get new batteries for my combustion gas leak detector, I'll check them out more thoroughly. The gas detector is working.
Okay, that's it for the gas piping. So the final thing was to install the PVC vent pipe. It's connected to the vent inducer with this rubber connector that actually came with the new inducer. So that was convenient. This is 2-inch pipe. Goes up into a 90. I use long sweeping turns across a little bit of horizontal section into a street L, 90, another 90, and then as you can see, right out through the foundation. This is temporary, obviously. This is just holding the pipe up. It originally had a 3-inch pipe in it. This cardboard I shoved in there just to take up some space because I ran a 2-inch this time. So the original vent pipe was this 3-inch PVC pipe that I took out, and it connected to the top of the vent inducer with that reducer there. That's 3-inch down to 2-inch. But I couldn't use any of that 3-inch pipe. For one thing, it came down and went over that way. But then, because of where the water heater is now, it's too close to going out. There needs to be a certain horizontal distance in the pipe. So it was farther away when it was down there, so it had enough horizontal pipe. In this case, I really didn't need to have this double 90 here. I could have gone straight up and out and over and had just two 90s in it. And this is even too close, really. I don't have enough horizontal pipe. But what I do have is 3 90s, and each 90 is equivalent to a certain amount of straight pipe. Plus, this horizontal pipe going out is much longer than this horizontal pipe. That's actually 3.5 feet. I'm going to cut it shorter at once outside. That's not done yet. So I'm going to show you how I cut that pipe and put the final fitting on the outside. But the total amount of horizontal pipe I have now is, when you combine it with all these 90s, the length of the pipe is well above the minimum requirement. So that's why I had to use 2-inch though. It wouldn't work with 3-inch. I couldn't, unless I did like a long U-bend or something to get a long enough pipe. It requires a certain amount of pipe. And I'll go over that in the video. I'll show you what it says in the installation manual. The minimum pipe length requirement is 1 1-foot vertical pipe, 1 90-degree elbow, and 3 feet of horizontal pipe. And with 3 90-degree elbows in the run like I have, the maximum length is 32 feet. It's pretty simple to understand. The vent must terminate in a 45-degree bend, and it needs a screen inserted in the termination to keep critters out. For the 2-inch vent, 1 90-degree elbow is approximately equal to 6 feet of pipe. 1 45-degree elbow is approximately equal to 3 feet of pipe. But so I also have to fill up the opening there. It's an opening for a 3-inch pipe that I have a 2-inch pipe going through. So I have to pull that cardboard out and fill that void with some cement. I guess I'll just use some mortar and fill it in solid with mortar. This is what the 2-inch PVC pipe looks like coming out of the original 3-inch hole. And I mixed up a little concrete mix to initially fill the void. This concrete mix contains stone. Playback is sped up here to save time. I packed it in there until it gave a lot of resistance. It's probably 2 inches to 3 inches thick.
With stone in the mix, you can't seal some of the tight spots. Here's the mortar mix. There's no stone in mortar. I spread a coat of mason's mortar to fill in the smaller gaps and smooth the whole thing over. I used a small trowel and did my best to seal the tiniest gaps. I have a bit of a gotcha to deal with. The additional considerations for installing the vent termination include insulating the pipe if it's exposed to cold conditions. And they say do not extend exposed vent pipe outside building. I know for a fact the original 3-inch vent was extended outside the building, but they recommend installing it as shown in the diagram if it's going through a brick or masonry wall. They want a sheet metal shield on the masonry, and the termination fitting should be installed right up against the wall as shown here. The original water heater vent wasn't installed that way, but the furnace vent was, except that doesn't go through masonry. I'm thinking the goal of this recommendation is to prevent condensation from forming in the pipe and possibly causing a problem, like freezing. And pitching it downward will prevent condensation from building up and freezing in the pipe. After all, the exhaust is warm when it exits the building.
You should be able to see on that bubble level that it's more than half a bubble off, so it's definitely pitched downward going that way. So any condensation in the pipe will drain out. So this is going to be the 45-degree termination I put on the end of the pipe. But notice that it's got that screen in there that they provided. I actually removed that from the original pipe and cut it down to fit. But I also cut this little piece here because I just want to make sure that doesn't fall out. So that's going to block it. And I could probably put some cement on that, but I don't think it's necessary. That's never going to blow out. I'm going to leave 1 foot here sticking out. Cut it to that length and then put the termination fitting on it. So it's pretty easy to get a straight cut on this. Just make sure that shoe is level on the saw, and that you don't have it tipped this way or this way, and you can tell that just by eyeballing down the blade that you don't see both sides of the blade. You just see the very top edge. Now normally you would want to use some PVC cement on that, but there's a reason why I'm not doing it on here just yet. And it doesn't really matter, that's not coming off.
Due to the higher air velocity in the 2-inch pipe compared to the 3-inch pipe, the exhaust is louder. The 3-inch pipe is a lot quieter. However, in this location, the sound really isn't excessive when you're inside the house. And the farther you get from it, the less intrusive it becomes. My neighbors will never hear it. Thank you for watching. Please take a moment to like and subscribe.